Let's start over again. Oh no. No. I had to restart my computer. I mean a cold start, and since I'm powering my microphone from the USB, I have to turn it on again. I'm so sorry. Okay, I had hardware issues today. Let's start over again. I started OBS and then I had an instant blue screen. My PC restarted, and then I was just about like 2 minutes late, and the capture card was not working, so I had like to turn it completely off and do a cold start. I think this could be this oven cheese, a different thing today. It could be in the oven for a little bit more, I guess. I don't know, maybe we will. Oh, you know what? Boop. And then let's set it to 100. What was 110, 120? There we go. Let's cook some cheese here. It's not as stinky. And I have some. Yeah. Anyways. Oh, Rota is here. What? Okay. Hello Dutch, hello Johnny. Hello Casper. I have some cold tea from yesterday. This is what I mentioned before, when nobody can hear me. Fu, hello, and thank you for the premature donation. That gave my PC the kickstart. Hey Thomas, hey Dutch maker. Rota, no, super sticker. Thank you very much. Hey Sonic, hey TMK. Oh, what? What is stream streak? Nice. Oh, yeah, the potato vision is not my fault. I have no frame drops, no nothing. It's streaming in 6 megabits per second. And that's the recommended bandwidth. Okay, so regarding the hard, oh yeah, you want to see the different I received all the components here from LCSC in the meantime. Here we go. Ta-da. Ta-da. And I also got this here. We can take a look today. Do they look familiar to you? Should we try one? But I think they are so yeah, we will try. I hope it's the right size. Yeah. I didn't try it. How do I open this? Okay, I don't want to waste one because they're like 150 or some, or 50 cents per piece. Okay. Focus, focus. Yeah. No very lock action today. Yes, it fits. Oh, so cool. Okay, I found LCSC connectors that fit. The mezzanine stuff for the nice. That's a win. That's a win. Nice. Here's the C number for you. Please don't buy them off. I really want to. Yeah. Of course, I got also the crystals that were missing. So here is. Now we're working with cluster today, but I have like one issue with the coding. All right, so someone mentioned there was a drift last time. Who mentioned that there was a drift? So the last three are the 12 picofarad crystals, and the other ones are from Mauser 8 picofarad crystals. And there is actually a drift between the ones with 12 picofarad and the one with 8 picofarad. We could trim that, but I don't care. That's just a test board. They will be all using the same crystals in the mega ultra super duper cluster thingy. Let's see. Oh, there's a new version available. Not now. I will show you the progress what I was working on. It might take a while to load. Let's eat some cheese. Oh, that's not a here. Look at that. This side is done. Like this bus, I could optimize it a little bit more. Add where, yeah, macaroni. All impedance matched. This side isn't done yet. That was what I was about to start before the stream. But can we see it in 3D? What happens if we press 3? Oh yeah, it actually renders it in 3D. So this is what's the dimension again? Does it say? We have 20 by 27 centimeters. So basically like a print bed. And on the back, I added some new. Oh, well, what is the rotation again? This is the rotation. Here. Look at the test points to program everything. How many pixels? These are 1024 on this blade. It's 32 by 32. But there are like 32 extra pixels here. I have an issue with this one. Like the blue channel is connected to GPIO B10, which is PWM 2 channel 3 remapped, but it doesn't work. I can't get it working. The B pin works. I tried that, like just writing high or low, but remapping the PWM didn't work. I don't know why. So I will leave it like that because I think I will use this LED if I will even populate it as a status LED. Mega jig? no mega. This will be just and then the mega jig needs like a mega jig to be programmed as well. Not happening here. You can't make sure that all the, like if you have 3000 pogo pins, you can't make sure that all are having a Perfect connection. The force to press it down will basically destroy the PCB. Anyways, this is taking progress. You remember what I said about the PCB, the power supply last time, where I had to pay like $700 instead of 450, what we saw online because I was late. Apparently, I got the last power supply in this region, at least. That's why it was so expensive. But it arrived. Are you curious about that? I guess it might be like B-Ware or something. I don't know. I would take it. Yeah, this price is probably... Do we open it? Do we enjoy it? Hey Jordi, you made it! If we open it, we have to keep it. It's so heavy. It's like, I don't know how heavy that is. That feels like it could be 7 kilograms or something. Is there something on the box? It's so much copper. Yeah. Sorry. Let's open it. You deserve it. I just need something sharp. Yes, it is 3 kilowatts continuous. Oh, look at the experience. We get a QR code here to scan. Oh. Huh? No, that will take a few days. It just left, the iPhone left, just left the warehouse. I checked, it was shipped already, but here we go. I spent like hundreds of dollars on new equipment, and until that arrives, I'm not really willing to solder again because. All right, this is it. 3 kilowatts of power. Wow, this is heavy. I wonder how much this is. It's quite heavy. I tell you. PC bed. It is like, this is like one. That's probably like 900 grams. That's 750 plus glass bottle. So I guess it's at least 3 or 4 kilograms. Schedule is still as. Finally. Thursday to Saturday. Hey. Triva. What? Yeah, sometimes we had on Sunday was the last stream. If you missed that one, oh wow! Okay, this is what costs the most probably because of the raw material. The raw material price. Look at that. I need to read. The raw material price of the copper. Look at that, the box just exploded. plastic for... Oh yeah, that's... Copper gold mine. Yes, it is. That's heavy. Oh wow, that's a lot of cable. I like that there's a lot of cables. I think I will never need... This is like 10 years of warranty, so I will never need a power supply again. This is all I need forever. It probably even the fan wouldn't turn on if I put it in my PC right now. I have probably like a 400 watt PSU inside at most. This is hefty. But I think I have like a Be Quiet or something PSU. Can't tell. I forgot. I like big and slow fans that are very, very calm. If you'd get 12 HP, what? For the... Oh, you mean this the socket for... Yes, it is a membrane keyboard. I like the slim style. Really not the clicky guy. There is something inside here. I don't know what's inside. I will just open it and see. What kind of envelope is that? Probably some screws or what is it? Oh yeah, cable, ties, and no, doesn't need to be clicky. It's overrated. That's just... I tell you that. I grew up with a cherry, golden, whatever, clicky keyboard. Yeah, I don't like the noise. Wow. Oh wow, oh, what is this? Alright, here we go. And this is motherboard. Okay, this is the motherboard. This is the 12 volts. We just need... How do we... Where is the... Copper's becoming aluminium-based conductors will replace copper. Really stiff and brittle. Okay, because I think I have no shortage on cables anymore. This one, look at that beefy cable. This is an actual 3 kilowatt. What strands is... This is really stiff and thick. Look at that. This is huge flat contacts here. I have to use this cable. There's no way around it. And there will be fire with aluminium. Magnesium. C19 plug? What is C9? What does it mean? Is it like for high currents? I need to find out. Oh! It's only 1.5 millimeters square. That's not a lot. Yeah. What? Not mix matching other PSU cables. Yeah, we need like connectors for our design later. Wow, this is heavy. This is so heavy. Amazing. Look at the caps. There you can see the caps. Can you see the caps inside? Are like the huge capacitors there. Ferrite cores, capacitors. Oh, okay. So this was the PSU. we are covered. Now we need to cover the 12 to 3.3 volts somehow. I have no clue how. This excursion is already so expensive. I spent 1,000 bucks, euros, not dollars. Dollars that would be like 1.5 already. So, like 1,000, more than 1,000. Oven cheese is doing well here. I think for this kind of, like, look at my mess. For this kind of cheese we need higher. Oh, you have some good news? Thomas, tell me. Tell me the good news. I hope you found something off the shelf that's trimmable and has some good protection. All right. Do you see the drift already between these here and these three here? You will see in a minute. How to close this piece? Oh, this heavy chunker. Need to close the box. Trimmable because I want to go down to 2.8 volts if possible on different lines. I want to power, look at that. So we have different power lines. Oh yeah, let me show the polygons here. Uh-oh, I clicked something. Don't click anything. It will destroy something. Yeah. Bottom layer. Okay, so I have different say power lines for the little MCUs, the LEDs, and the main MCU, GPIO, and core voltages here. So all different powers, and I will put them all to the connector here. PCI Express connector. Doesn't show. I think I turned off mechanical. Yeah, I need to also place that. I don't know. Change the shape. Also the LED, everything above 2.8 volts is a waste, so I need to balance that. That would be great. I can run it from 3.3 volts, but we will waste a lot of power. Yes, that's a big issue. So expensive. Okay, let me check that. What's so special about that one? 3 amps? We know that one already. Or a similar one. I mean, this is the same thing that I used on my board. What? The DC to DC converter? Jody. We will put as many in as necessary, so basically the current to dollar rate is what matters. If you have one that can provide 10 amps, cost like $3, and then you have one that costs 50 cents and can provide 2 amps. Probably the one for the smaller one is worth it. Or not. Not sure. I ran out of bread. Reputable, cheap on quantity. Yes. Oh yeah, you're right. I think I used that one. Does it have like enable pin? Efficiency is 80% at, what is this? Output current up to 2 V out 3.3. No, it's already 90% up to 2 amps. Then it drops. Not bad. Yeah. You can see output 3 point. So we're moving around between this line and this line. This line touches 90% at 1 and 2 amps roundabout, so this is 3.3 volts. Typical configuration. Okay, yeah, no. Also, I need some Zener diodes there. 3.3 volt Zener diode or whatever. And how do you do it? Oh, you can see the phase shift already. Here. Or some way. Some way of turning it off when we surpass voltage. I need some serious protection there. So this one has an enable pin. Yeah, if you find a module, that's good. Let me get some bread. I'll be back in a second. I need more bread. Here. Yeah, they're not drifting. They're just They are probably more precise than these ones. These are running too fast or too slow. Focus. You want to focus? At least it's working fine. No, these are 12 picofarad. These are 8 picofarad. And they are internally, like the internal capacitance matching is set to the default, which matches more the 12. So I could trim it. 1024 cores per blade plus the 32 or 34 FPU cores. Stating facts is racist. What? What? All right. Shall we code a little bit? Or do we edit, or do we see what I eventually bought on AliExpress? What do you think? What do we do first? I already. You want. You all are addicts. Okay. The first LED. Which one? They're all fine. Okay. I don't know if the what tips I included with the soldering irons, but let's start with humor. Yeah, it was okay. So first of all, zoom in. Why is it? It's so shifted. Okay, I got. Yeah, I'm not clicking on the order details. So this one first. Wait, it comes with the tips? Okay. I should just look at the picture because I got just more tips. Then I got a set of these here. $35. So not the cheapest. Come on. Yeah, so set of whatever for the power supplies. Wait, which one did I get? I think I get the one that had at least 2 of those precision. That was that. Then I got another power supply. It's so funny. It says 85 watts, but the picture says 65. I just got another one because I'm always running short on power supplies and no harm done. Something in between, yeah. I don't know how good they are. I just got some of those. Then I got the Nanoflux. Then the other iPhone with 3 tips. Oh, damn it. Why did I order the tips separately? Then Soda Iron Refresher. 2 of those. Look at that. 2. We can stack them. I got this one because I liked the red. Then alcohol bottle dispensing, rosin washing. Then another brush, anti-static motherboard PCB cleaning. I tried to get some lights. I just testing. Microscope lights are so expensive. If this doesn't flicker, I can just take 2 of those and then plug them around my microscope and have better light there. But I'm not sure if you get anything good for $2. Oh yeah, this is cool. Finally a good solution. Look at that. With magnets and the plate. So that looks promising. If this works as I expect, OmniFixo. What is the OmniFixo? Hey, live. Let me check OmniFixo. Looks fancy. Yeah, it looks fancy and cheap. So if anyone wants to try, I will give you the link once I receive them. I see that. OmniFixo. Okay. Here. Yeah, that's cool. A little bit more expensive. Yeah. Then we get something from the Pink LED fund. And then for soldering iron tips, $6. Then I got this here. I don't know how, probably terrible lights. I just testing. It's $5. And I got what did I get there? A set of tips. Hey Eddie. I think I need to set the temperature even hotter. So this is the order there. I didn't place any other orders. Johnny, thank you very much. Pink LED fund is replenished. That's amazing. Thank you. Very generous. I don't know how good they are. I don't even want but there was no cable, silicon cable that you can get without the display. Foo! Thank you. So Jesus, what? For pink LEDs, yeah. You saw Jesus in the bread, or? I'm confused. Saw that in your eye. Okay. How did that turn out? You know what? I got a stick in my eye last year, and the video went viral on TikTok. It's the best video I put on TikTok ever. I tell you, this year is the year of the excavator. Yes, we have Discord. link.bitluni.net/Discord. Ah. Foo. Wait, the link for the TTS is terrible. Okay. Here we go. You can this is only, this is for the TTS if you want to. So that was the shopping spree. Oh, by the way, Fu, you gave some money to the Colombian Coffee Fund. To the Colombian Coffee Fund. And I went to the shop and I actually looked for Colombia coffee from Colombia, and I wasn't able to find any at Edeka. Edeka is a common grocery store here. I only found Peru and Brazil, but not Colombia yet. Maybe we can research. Does anyone know like Colombian coffee that you can purchase in a grocery store here, like a common one? Yeah, Arabica. I will take Arabica. Oh! Oh! Okay. But I don't, okay, the full beans, I need probably like powder, but I think we have something to shred them. Juan Valdez. I didn't see that one because I looked for powder. Chibo. Oh, wait. Here, but it's always like full beans. Intensity. Oh, okay. Chibo Arabica. Okay, let's look for. But now I know what to look for. But I tried. I checked already. Juan Valdez. You mean this one? You can get it off Amazon. I even have Prime. Oh, Robusta? And so why do you ask? You should just recommend robuster then. Okay, so question was, how do I find Altium compared to KiCad? KiCad is certainly on the difficulty level right in the center between Easy ADA and Altium, I would say. So for like the basic hobby things is probably KiCad enough. But for professional collaborative work, the learning curve is quite steep. I needed like over a month to get used to everything, and I still don't know all the tools. But they're like super handy things. Like if you, the best thing is, one of the best tools, you don't know that it's good until you are working on bigger projects. It's just the search, the object search, and then you can filter. Let's say object kind via is the same, so you will filter all vias. Then you want to select all GND vias, and let's say something else, like maybe diameter or something, or expansion, different parameters, and then you just click OK, and then you get all them selected. This is now a huge project, but you get all the vias. Look at that, all the ground vias are selected now. Oh, what is this? I don't like that. Will probably be connected in the final thing anyways. Yeah, that's one cool tool. Of course, the versioning is cool. Collaborative tools like you can do tasks. So basically working as a team. This is quite amazing. I have fewer crashes than with KiCad right now. I'm not sure if it's like what the state of KiCad right now is, because you get like a version every month. The visual difference. Oh yeah. My multi-screen setup is super annoying with KiCad. It always zooms like the scales the windows to full desktop, which spans over 3 of my screens. Altium has a different issue. I had like sometimes I have a pop-up box that plugin system. Scripting. So I actually wrote a script to clone the design, the placement of this first design that I did, to clone the placement of the parts to this side and this side. But there are like rooms you can work with that are also cloning not only the part positioning but also traces and stuff. But yeah, you can. There's so much stuff in Altium. Oh, one amazing thing that I miss on KiCad. Probably there is a plugin. I'm not sure. I don't know if Altium is $1,000 a year, so you need to be sure that you want like to keep using it. Otherwise, I mean, you can still access your project. Yeah. No, it's $1,000. They changed their pricing. Altium develop is $1,000 a year. Roundabout. That's my latest info. We can check. Okay. Yeah. Per author. Oh, wait. Subscription activate chat. Author enables authors collaborators required to get started. Okay, so it's 2K. Because you need like the workspace and an author. Do you get an author for free? No. So it's basic. Okay, yeah. It's 2. I was wrong. Sorry. The more authors you want, the more it costs. Dip trace for life. Yes. Mm. I don't know how comfortable it is. That's what I mentioned, like collaboration on project. Like if you work in a team, on a team, it might be difficult to handle. You can still use Git to version your stuff. Um, I guess this is like more integrated here. Also, like tasks, you can maybe let me show you a thing. Do I have panels? There are so many features. I'm not sure if it's easier. I don't like. I mean, you can use even JavaScript. I, I was I was recommended by Gemini. Gemini spit out Delphi. So where is it? Comments and tasks. So this is something. Place a comment and then you can just select a part and then basically add a comment, assign the task to like a collaborator, let's say fix the ground. You can let's assign and then severity. I think you can even whatever, but you can just no authoring spots. Yeah, that's because my PC crashed. Something like that. That's yeah, and then it will be shown to anyone, and you can resolve. Yeah, I'm not connected currently to the workspace. I need to close that because currently mine is currently no, nothing. Yeah, if you hit the limits, move on. Type and miler for life. Dip trace it is. Yeah, if you're working as a professional, probably there is no way around Altium if you have the requirements. I'm not sure I got used to it. I love some of the features. On other features, it feels a little bit dated, but it's yeah. Oh yeah, one thing that I like is manufacturer part search. You have like a huge library of manufacturer parts. You enter the part number, you get the model, everything. It's not like you get models and schematics parts for everything, but they have like whole database with data sheets and everything linked. Anyways, I wanted to code a little bit and you try to help me. I have a slight issue that what. Oh no! What's. Oh. My hard drive is full on the. Oh, that's cool. Share it here. Share it in the chat again. Bump it again. Also on Discord. My hard drive is full. I did too much OBS recordings. Okay, do I need this 12 gigabyte video? Okay, can remove that. We don't need like 12 gigs of something like that. Alright. Sorry, I'll be... So PWM... Hey Wagon! Alright, so... The issue is... What is it doing? Blinking right now. Okay, so let me show you. Okay, I have B0. It would be red. Turning on red. Let me upload that. Can we see that bigger? Get the camera closer to the ground. The legs are too long. Ah. Code protect. What code protect? Oh, wait. Ground detached. Here we go. Whoop. Okay, you see. No, you see nothing. Here. You can see the red LED here. So. Now it should be brighter. Wait for it. Oh no, it's less bright. Okay. And then even less bright now. Okay, so this PWM works. That's B0. But B10 doesn't work. Oops. B10 doesn't work, and what we are doing a full remap. Didn't I save that? Where is my other remap? Okay, pin 10, timer 2. So more and more, they don't have floating point, but they have some bit operations that support the conversion, and they also have multiplication and division internally. Like compared to my other clusters, like this one didn't have multiplication. So when I use that, if that works, it just doesn't turn on. And the data sheet, let me run Foxit. I hope I don't dox myself. Sometimes I have like documents open. Oh, Foxit reader. Okay, here we go. So we need to implement in code. Yeah, it has the umph. So the array marcher that I used with the other cluster had like for the square root reciprocal, like fast square root RCP by John Carmack from Quake, is still, compared to the other methods that I tried, was still the fastest with conversion to float, doing the bits operations magic, and then converting back from float. But you need to count the leading zeros, and this is quite costly because that takes you like a few branches to check is that a zero shift, is that a zero shift, and do on and on. So it might take like, I don't know, 16 cycles just to get like the leading zero count. And this MCU specifically has the bit operations that do that in one cycle. It just can count the leading zeros, for example, which like super amplifies the conversion to float. Yeah, and of course, like not having to do the multiplication with shift operations is a win. I don't know how the compiler converted it, if it just put that in place or if it was like implemented like a function. Anyways, maybe I missed something, people. This is where we are. B10, pin 29, B10. This is what, so I'm using B0, B1, these are working, PWMs, and B10 on pin 29. Okay, let's get to the list. Here we go. B10. Okay, before we had B0, B1, timer 3, channel 3, timer 3, channel 4. I was able to use that works. And then we have like remapping and PB10 remapping function. We can do, since there's like no timer initially, like with no remapping, there's like timer 2, channel 3. That is an option, and I thought, okay, yeah, I can use that and remap that, but it didn't work. I'm not sure what happened. Let me show you that. And so this is only available with PB10 here. Here you got it again. Multiplexed function remapping, and then you have timer 2, channel 3, partial mapping and complete mapping, both like versions here, and it maps the timer to PB10, and I still don't see anything. It's floating when I try that. So here is, oh no, I opened Visual Studio Code. I don't need that. So let's take a look at this timer. It was timer 2, channel 3. So we enable peripheral. So these are correct. We enable the peripherals. Alternate function push pull. What? Before you know it was? What did I miss? Oh, Myland was, oh no, sorry Myland, your message was filtered. Somehow I missed few things on Twitch chat. Anyways, here we go. GPIOB is initialized. Then I have like a full remap timer 2. Oh, there's an issue with a clock, like world time. Atomic clock not working. Yeah, my clock is always off. Okay, then the configuration. We tested it. We set up timer 2. If I have a 10 megahertz reference, sure, my oscilloscope probably has a reference. Okay, pulse width, and then we have channel 3, timer 2, and then the structure, then timer to enable, preload config, oh yeah, okay, yeah, I don't have a reference then. Timer to enable, timer to, so this is like whatever I do with the channel 3, same thing happening here with timer 3. There is almost no difference except for the pin, and I'm wondering if I need to turn on peripheral GPIO-A, because the initial one, if this is like a weird behavior, because initially timer 2 would be present on PA2. So what happens, let me enable that, and then we can basically test with the scope if there is anything appearing on that channel, or if the remapping works all of a sudden. Alright, scope time. Oh, there's too much stuff on my table and I bought even more stuff. Oh no. Regret. Instant regret. Ah! I love the new power supply. 3 kilowatts. Okay, how do I do it? What? All right, here we go. I hope that someday they will build oscilloscopes that are not noisy. Probably nowadays already, because I don't like the fan noise. Did you know that I am now really healthy? I went swimming yesterday to work against my nerd neck. I need to get rid of my nerd neck now. And when I'm swimming, I have to do it like that. Disconnect the fan. You modded your Noctua? But they have like the throughput is different. How do you match the throughput? Did you check what the specs are of the fan that's internal? Oh, Maruo Bon, thank you for the hint. Yeah, the remap might be bad here. Okay, I will try to enable A. I think that's Perry 1. Is it A? It will complain. Yes, alternate function. Oh no, it's Perry B2, okay. Okay, so let's enable 2 first. Okay, didn't change anything. Also, let me do that. what was the original pin? 2. Yeah, channel 3 was pin 2. GPIOA. And then we have just to find GPIOA if that's... I'm not sure if the remapping function... I tried to write hardware remap... Oh yeah, here. Wait, that wasn't the wrong... Yeah, that was here. That's my hardware, my remap. Maybe that remap didn't work. Okay, wait. Let's try remap here like that. That's the register. Nope. Don't see it. Okay, now let me check. Just connected to my bloodstream, so it's always okay. Now we need to find A2. Where is A2? A2. I think this is VCD4. No, this is 100 pin. '60, 70. 3, 7, 3 VCT 6. This is it. No, this is not it. 60, 64. This is the one. EV10. Where do we have A2? Oh, A2 is actually quite conveniently placed. Here, that's the side pin here. Whoop! It's high. Why is it high? Huh? Oh no, that's the wrong one. Eh? What? No. This is the one. Sorry. Yeah. Okay, remap doesn't work. Remap doesn't work. Full remap timer 2. Remap doesn't work. Or remap needs to be done at another time. What do you say? Remap. Wait, maybe there I missed like an example with remap. But I used remap before. You did remapping at any time? It just works? I'm trying to remap a timer, but it doesn't work, Thomas. PWM 6-step. What is 6-step? Phase shifted, synchro, external. Okay, let me open just another phase shift thing. I want to remap the timer to another pin, but it doesn't work. The timer is initialized correctly, but the remap function, okay, I show you. No, this is the wrong one. Oh no, it is clipping output. Okay, I tried pin remap. Third timer example. Which one? What's the name? Because I changed the example here, this one. I had remap before. I used it before. I need it for remapping here. This is what I did before. Oh, ho, 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 ho. Alternative function IO. Needed for remapping. What? So I had this issue before and I didn't. Oh, now it works. Here. We have green light, pips. Green light is blue, but it's green now. So here. Yeah. Also, oscilloscope says yes. Yeah, it's always the missing clocks. Okay, now I'm relieved. We don't have to change anything. It's working perfectly fine. That's cool. All right. Woo! So Deshipu, by the way, welcome to the stream. You're working with those all the time already. Because do you use like also the second version of a River Studio? I dabbled a bit. You're stuck. We're stuck with what? Please tell me, your projects are most interesting. Did you book your flight to Milan already? Or where is Hackaday? I'm not coming, I can't. Oh. 208. Wait a second. Let me think about it if I got it working there. I know. Oh, no, I didn't use 308 yet. I had like different codes. Let me think. Shoot, where did I use it? I used it with the mini game that was the X35. That has like the full stack implemented in code, no library, I believe. Yeah, and that didn't work. Have you been able to port that? I'm wondering where else I used it. It rings a bell a little bit. Did you at least list the device? How far did you get? Did you get like an ID or whatever already? Foo is probably capable of helping. He did a lot with the MCUs, if he's still here. Alright, I need to turn off, remove everything that's not necessary here, so we don't need that part. I need to create a new project. Oh, you don't have the energy. I feel the same. I feel so like weak. I'm exhausted all the time. The plugin for key. Oh. Updating for what? Have been there changes? Oh, there is some weirdness going on. Like who of you co-signed parts with JCPCB? It's so, it feels so complicated. I don't know if I just need to get it done once. Hey, Taran. This 2 years ago, ITT. So today I finally, since people are coming in China, coming from vacation, I needed like to provide the Chinese address. You need like to click a button to copy the address of this dude who receives all the parts, and it's so like, I don't know. I mean, I never did this before. Now we're trying. So I'm getting 10,000 MCUs, and we will be able to assemble the first full blade. And I'm so scared if that doesn't work, and I have to botch 1024 MCU board, or the parts you get bit, yeah. Yeah, you send, there is, yeah, so how it works is, yeah, maybe I can share. I don't want to dox myself. Okay, let me switch that. Oops. Alright, let me sign in. So basically, if you want to send parts, please don't dox here. Okay, so you have to co-sign parts. You look, if the parts are already in the library, you look at the parts. Let's say bodging those fish. Yeah, probably not if there are power issues. It's just trash. It will be for display, collector's item. Yeah, and then you can, okay, let's say, look at my parts library. I have 116,000 parts. Look at that. I stashed already the full amount of LEDs that I don't, I hope the excess that you need like some extra, like 5%. And I found the similar LEDs, RGB LEDs from, because I bought basically all of them that were available on LCSC. I took like the full amount, and then these are similar. It's basically, I guess, no, what, wait, this year, different companies, same LED. I just bought 20,000, and I think I will use those for the main MCU. That's the one that we try to configure right now. Then I bought crystals. I think I got 10,000 crystals or 6,000. Yeah, I got 6,000 of the 32 megahertz crystals. So I'll be able to assemble 5 boards at a time. Also, yeah, And what I'm missing is, like, if I order parts, let's say JC parts, and then CH570D, CH570D, you will find it's not stocked. Yeah. You can only pre-order and the price isn't correct here. You wouldn't be able like to buy it. So there is like no way you can purchase that, but you can co-sign, and then if you enter like 10,000, that means you buy them elsewhere and you let the manufacturer or the supplier send it to JLC. And there is where the weirdness starts. Yeah. Who bought them? I didn't buy them. I don't have them. I'm already testing with the 72 version right now. So they're quite similar, but not exactly the same. And more pricey. And I really need to like the 570. So then you will get this here. Now, the next step is to co-sign. There is a button down there. Co-sign. Okay, I don't need the clerk. And then you need to go select either mainland or whatever, and you need to provide the tracking information of the package, my contact information, the pricing, upload the invoice. So there's the weirdness for me, because that's samples that I get. So 0, I don't know. Then the application or country of origin, okay, that's mandatory. And then here is where it's hidden. So you will be extra charged if they're not like labeled. I don't know what COO is. I hope it will be labeled correctly. But if they're sending like reels, that should be fine. And then you send it to Chris. And this is where it gets really weird. So you send it to Chris, but then this is my account number here. So you can see. Wait. Let me turn off the LED. So I will update you on my experience with that. So you send it to Chris with your account number here. This is Chris's phone number, and it's S&T warehouse, floor 6, building 5, Advanced Electronic Factory, number 2989, Zhongfeng Avenue, Dongguan District, Shanghai City, China, whatever. So and I gave this address to WCH, so they will be able to supply the MCUs. And they requested the Chinese address. So you don't see the Chinese address. So I poked the support here, the chat. Yeah. So I don't know if it's here. If you press copy and you paste it, here you go. You get the address in Chinese. What? You need to know things like that. How do you figure that out? You need to know that you need to open, like click this here. I didn't see that. Technologia, yeah, Technologia. And then you have to know that you have to press this button to get the Chinese address. And then still, I'm not sure if what they do if I don't upload like an invoice or whatever. Let's see. I will find out tomorrow morning. They're like 8 hours ahead, so I guess they will start at 8 o'clock. So the the first messages will arrive in the night, and I hope I will wake up early too, so I can respond. Otherwise, it will take another day or two. So, as soon as the parts ship, I need to like finish my PCB, like the blade, and make it happen. Tips. I'm really curious how that will turn out. I hope it won't be a total disaster. It like just ordering one board assembled is a huge waste because they manufacture multiple boards. On the other hand, wasting the parts on 5 boards if they don't work, I don't know what to do. There should be like something in the middle where I say, okay, please keep the boards stocked, and then put them somewhere, and I will test the board. If it works, then you get the green light to manufacture them. Thumbnail. That's right, yeah. A disaster. Yeah, but we need like to show results quite soon, I guess. March is the goal, to show results, and then we have like still figuring out like supply, the mainframe. I just realized that I don't have like a printer that is able to print diameter of 60 centimeters. So if I have like the container and I want a case that I put on top of the container or whatever, the glass tube, I need like to either I don't know how to do it. The biggest one can do 250 millimeters. Automated? Nah. JC 3D. Yeah, 3D. SMT with the pump, pixel pump. Yeah, that would work. Yeah. I think that's not the pump. We need like better suction there. Gross. So I'm healthy now. I told you I'm going swimming now. Tea, and I'm drinking water. No booster today. Nah, only no booster because I was too lazy to go to the shop. All right. Yeah. So I will keep you updated on the weirdness of co-signing parts with JHC. Really curious. Once I figured that out, it will be easy. I will just like stock them up with giga thousands of parts and do my thing. At least I got 70,000. No, what is it? 80,000 LEDs there. If everything fails, I can still use them to make small RGB LED screens or whatever. A nice dev board with a little RGB LED pixel playing game. You finishing the post on the Discord? Yeah. Okay, so we figured that out. I want to test SPI now. A ping pong wall, but then denser. Yeah, basically something like that. Or like my mini game that I did before, but nicer. Like this one. This one, but with RGB LEDs. I like that. And then Loonyism. We wrote everything. Like we even had Loonyism. That's what we used with the file system for. We were able just to drop a Loonyism object file or compiled binary there. I totally abandoned that project. Why though? I loved it. I liked it. We should revive it. JLC 3D? for manufacturing? I could. Okay, let me check that. Or we let it manufacture from printing CNC, like metal, 60 centimeter diameter metal part. But this part isn't for euros 24, huh? Turning EDM, sheet metal, 3D print. Oh, yeah, 3D printing. Ooh, that looks nice. In days. Does it support Europacket? Instant quote. Okay. Let's order now. Upload model. Aluminium sheet metal 3D printing. Yeah, we would need like to design it first. Did anyone test like bigger prints with that? But probably have to like do FDM. What? Thomas. Be careful, you know, like there's like air carrier, like 2 air carriers nearby. The conflict could start any minute. Oh. Oh, my chat is frozen again. Nuke, run, duck and cover. But they wouldn't attack like the civilians, I believe. Yeah, DFJ, you missed it. I paid like $400 for stuff, and you missed the power supply. I will show you. It's like so hefty. The 3 kilowatt power supply. Oh no, where is it? Here. Ah. Okay. Yeah, the PSU is like just kilograms of copper here. So we got 3 kilowatts and 12 volts. All right. So how do I start a new project? New file, new open project. I want, because this is like all an example. I don't want like to work from within that example. Okay, let's make a new window, and then create Mon River project. Okay, let's do that. Right. What did you update, Fu? Let us know the latest news from KiCad world. Ooh, multi-core. That's what we used before. New API? All right. Did they update it? Oh, the FGA. What specs does the LED driver have? I found quite cool parts. I mean, I like for this board here. For this board, I needed like high side and low side drivers, and that's only LCSC parts. So I found quite good ones, but they're not easy to find. Also smaller ones than these, because these packages are quite chunky. If you see that, I found like even smaller package for that. Money from YouTube. Yeah, but I don't like if you create an arc that creates like high voltage spikes. I don't think that would go well with the internal components of the power supply. It's probably not made for that. Or did he use actually that specific PSU? Okay, which one is it? RTC, CBT, VTC, RTC. Is it RTC? I think it's RTC. Which one is the 64 pin? It's getting cold outside. Who of you went outside today? I mean, the people from Central Europe. Hey, Quindor, you missed all the goodies. The 3 kilowatt power supply. You missed that. It's right in the beginning of the stream. Yeah. You you need the high frequency for aluminium to basically get rid of the oxidization on the surface. It blasts off the oxidization, the arc that you get, like the high frequency arc. So I have actually one that is capable of doing that. All right, let's open up my schematic again. And load already. It's loading slow. Oh yeah, it's loading the board. And NVIDIA wants to do something. All right. RCT6. Okay, that's the MCU. RCT. All right. Project name. Ultra level 1. We start at level 0. This is Moon River projects now. Okay, here we go. I hope it creates a subfolder. Oh, the sheep, no! You are an important member of the community. Oh yeah, okay, it created a subfolder. Nice! Maybe Oh shit, you know what? It's bad. You know what? I close it. I create a folder. Okay. Maybe I should just, you know what? I just delete it and create a new one. Oh, Wagon, you're, oh, yeah, you're East Coast. Where are you located again? I know that there is like a super snow blizzard on the East Coast recently. Like New York completely shut down for that. Ah, okay. Are you alright? Delaware. I only know Delaware from Wayne's World. But the German joke didn't land very well. That was from Wayne's World 2, I believe. No, Wayne's World 1. Wait, let me check Delaware in a second. Ultra cluster. Okay, now we have a new, and I will do code. I will initialize. I will do it later. All right, peripheral. No, user main system config system. What was it? 120 internal, because 144 never worked. Okay, let's change that. Let's do nothing. Core clock update. Delay init. Oh, that's cool. Let's leave it. So we have a reference what to do. Printf. Include debug. Okay, Delaware. YouTube seems broken. Yeah, feels like my chat was also stuck for ages. Delaware. Here we go. Ah, yeah, it's right. Yeah, you're basically like next to New York. New Jersey. How far is that? Yeah, that's only like 200 kilometers. Yeah, so a lot of snow, huh? Is there a layer for snow? How do you get layers here? More weather. Is there weather? No. There's no weather. Yeah, Twitch works. All right, let's clone our setup. Auto blah blah blah. Note usat print routine. This example demonstrate blah blah blah. I don't want this. I want pureness. Delaware Memorial. I close the window. I want to set up SPI communication to the little MCUs. So we will work for another 1 or 2 hours. Plus the time that it takes me to process all the distractions. That's the memorial bridge. It's a big bridge. Cool. All right. Where's my example? PWM output. Okay. So we have B10. That is B10. That's so weird with the remap thingies. So we do new file. File name is LED H. Here we go. Init B10. IFU. Okay. Push pull. We need periods, and this is the output. Oh, really? How old are you, Wagon? B0 and B1. But I think we should do all in one here. Let's do all in one. All B10, all here. And then we just need to also recombine uh 570, not one. Okay, so all pins are enabled. Timer 3, 2 and 3. Timer 3, and then we need remap timer 2. Then we need period is or is it 5? Full is 5. Division 0, count at mode, timer structure, OC, PWM1. What that is again. Output state OC polarity. I think we can change that. Output state. That's basically OC preload. What is this preload? Does anyone know what that is? Preload. Peripheral preload register. Fast config. What is that? Okay, this is channel 3, then we need pulse is 0, we need timer 3, 4, 4. That's the general timer settings. And then this is let's say cycle. And then period. Settings. One. Yeah, timer 3 and timer 2. We need both. 3 is RG. Red, green, blue. We using the same timer, like with same width, whatever, to and then the pulse width is like a different channel. That's quite cool. We can utilize if it was more than like, if the pins were better aligned, we could use like one timer to drive all the LEDs, like all the LED channels. Now they were not next to each other, so we're using that. Enable, also timer 3 enable, and then we need to, whatever this preload config is, 3, 4, 3, 3, and then timer. I don't know if all this stuff is even needed. Probably not. ITT, I don't understand what you're talking about. Output compare. Oh, OC is output compare? No. Wait, what? Preload? Buffer? Is this, the preload buffer, is that the thing where you put like the new value and it will be just used on the next pulse, or that would be cool, because sometimes if you change it too quickly, Then oh, let's say not LEDs. Yeah, so I really want to have that actually. Preload enable. I hope it works. Because otherwise, if you update quickly, it might just reset the timer over and over again, and then you never see a pulse. Enable and then void set LED and R and G and B. Shola de Shamlavcha for preload. Doesn't search. Yeah, but it is almost the same. Let's do preload here. Preload transfer to active registers on the event. Ah, here you go. There it is. Capture control preload. We can just try and see what happens, huh? Okay, so we do this. Yeah, YOLO. We have the test article here. This is our test article. We can break it. We can replace parts. I have replacement parts for everything here. And then if we are sure everything works, we can put it on a blade and then no more experimentation. That no more harmful experimentation. That looks quite wasteful, but wait, this is OC init structure. I guess a few register writes would be totally enough, but I'm too lazy. Maybe we can, you know what? Okay, let's do it. Output compare, that's tim pulse. We need the tim pulse. This is it. We can avoid all this stuff just by writing. That's channel 3, okay. So let's see if we can do avoid all this by writing R, that's timer 3, channel 3. Sometimes, I mean, it's very hardware specific here. 2 channel. Wait, was it 4? Was it 2 and 3? Three and 4? SDI? What? What is SDI again? I need water. Water. Pew pew. No, I didn't port anything. I re-implement. We reinvent the wheel again. Let me check. B0 was OC3. Yeah, OC4. All right. Okay. I guess. Level 1. All right. RGB. Copy paste. Huh? Do you need more zoom? Here's more zoom for you. So, Fu, now I need your help. I program them once and then I will accept new code over SPI, either writing it down to Flash and running it from there, or running directly from SRAM. So I will show you. Okay, you know what? Give me a second, then we will test that here. Custom bootloader. Yeah. All the things. Init. And then I guess what do we do? Okay. It's not really testing the green channel, but I'm willing to build failed. Ah! Oh yeah, we need to include stuff, huh? What do we include here? Peripheral. YouTube chat is broken. Sorry. Do we have access to that as well here? Source included, yeah. Can we include, is this including everything? What is this main? Does it include anything? No. It's like pre-configured to include all this stuff. It's weird, this configuration doesn't do that. What do we have here? User. Or do we do this timer? Copy path. Not sure why it's not liking that. Okay, it built it. Okay, it is like a steady. It's not updating. Let me do manual focus here. Let's zoom in. Oop. Yeah, HDR, huh? Okay, so let me change. I'm wondering if our thing that we did with preload disable, if that was the issue. Or do we have to change it like every single time? Because I believe do we do prescaler? Wait. Okay, let me just initialize without doing anything here, set without set LED. Is it dim? No, it's completely off. So it's actually Let's do 4. In that case, in that case. Oh, what did I do? Oops. Okay, here. The LEDs look so gorgeous. I don't see. Let me do more. Oh, now I can see. Oh, yes, okay. Do you see that? This is now, this is 0.05% of the brightness, or whatever scaling like. Should we check what the pulse duration is now? I will turn on the scope and we will see. Okay, this shows basically we can make it really dim. 3 little dots. In HDR. Hello, Markus Karkus. Oh. Yeah. We are making a new ultra cluster and I'm developing the subcomponents. Currently this dimmed LED there in the corner. And hey Sean, by the way. Measurement. Where is it? Having trouble to concentrate a little, but we will figure it out. Measurement. Here we go. Okay, so frequency, LED frequency is 1.8 kilohertz. Is it fast enough? What do you think? I think that's fast enough. Point 1.8 kilohertz. Let's calculate if we're times. Yeah, 120 megahertz. That's spot on. Oh, you mean they actually are the weird part is, I mean, that's a quite close. They are perfectly spaced, but they are rotated by 180 degrees. And you can see because physically the filaments of the colors are like next to each other by, I don't know, 0.2 millimeters or 0.3 millimeters apart. I think 0.2 is more like that. So they're actually not like in one spot. Yeah. And also, if you see the reflection on the PCB or something, you see like blue is pointing in that direction and also, oh, that's so cool. The colors. I love color. Give me color. Now let's check what's going on with our let's do 2 milliseconds then. Yeah, these here, they have a different crystal. If you're wondering. You know what? I will do 10. So we will see, and then plus 1000. Let's see if that. Oh. It does something. Oh yeah, green is always fully lit. We need to invert everything. I forgot. We need to, I think, counter mode period. Polarity low. Let's see if that inverts everything. Yeah. That's working. Ah! Not my face. This thing here. Okay. Shutter. Shutter is doing nothing. Let's close the iris. Okay. All right, LED works. Now let's do the communication, huh? Nightclub. Okay. So this is now new file, and then we have SPI .h. Let's do that. Now we need to clone SPI from whatever. Where is it? SPI DMA. Ooh. Full duplex, 2 lines, full duplex. That sounds like what we need. Hard NSS. With so many options. Okay, let's start with the easy one. Oh, SPI Looney init. Okay. Apparently, we did some code before. All right, okay. So this is the alrighty SPI Looney init. Okay, DMA structure. Oh. Okay. Let's do that then first. Init SPI. Let's do 1 or 0. Or down. SPI. How do I call it? A and B, huh? SPI host. Init SPI host, and then we will do. I think this is still the same. Structure add SPI enable. We did something before, so let's see. Init SPI. You know what? I should put the debug before. That's why I probably have the issues with main core clock update Looney delay, and that was what I was doing. SPI I2S. That was what I was testing, the frequency of the SPI. You remember we measured 32 megahertz or something on the SPI clock or data. Clock and data. All right, so let's test that. SPI 3. So let's wait, let me do send host. Stupid name. Really stupid name. Entire cluster connected. Yes, I hope so. That's the goal. Did I use different naming conventions here? SPI host? No. Init SPI host. Send SPI host. Okay. Yeah, let's try. Now we can test a scope time. If we see SPI doing anything here, we have the lines that we can test. I don't see anything going on here. Yeah, not working. Need to be careful with this clamp. Maybe I will. Do I have like plenty of ground somewhere here? Because I might short something. Yeah. Core clock. RX in it, TX in it. B SPI 3. Okay, now let's check again. B Miso Mosi SCK B4 3 4 5 3 4 5 push pull floating B SPI 3. Yeah, that's SPI 3. No remapping. Okay, you know what? I tried the. Oh, I know what the issue is. No, I might know what the issue is. Let me try doing this in a while loop. Or let's leave it here. So we don't have like a delay that basically prevents it from ever showing on the oscilloscope. Okay. But I didn't see a clock either, so. Oh, there is something. Yeah, this is too far away. I need this ground quite close. We put it right here. Yeah. Yeah, that's 16 megahertz. And this is 30 megahertz clock. That's the clock, SPI clock. And this is the data. Right, that works. Now I need to send data over SPI to the little ones, basically to notify them, here it comes. So we need, what we need is send basically R shift by 8, and that's what we send as host, and then we also need for we have 32 channels. CS, and this will be basically I, and we do enable CS, and now we need something SPI prepare CS, and then we need also CS port, CS, yeah, pin is clear. Not sure if we even need like that. Ah. Oh, there is one issue. We need to disable the programming pin because they are overlapping with. That will be difficult because we can't power cycle right now, and I don't have a reset pin. I added the reset pins to I'm wondering if how fast it can switch on and off the programming pins. Or we do pull up. That will be way slower. Nah. Let's do that. But if we do that, you know what? We don't do prepare here. We do and then programming will be a hassle because we need to time it correctly. Like Tommy, we are trying to send over SPI, and the SPI pins are also the programming pins. So, not the CS push pull in its structure. GPIO. CS. One 15 basically, and then it's C, otherwise it's B. Really bad implementation. I don't care. Set. Oh, we need this. We don't need this here. It's obsolete because it's smaller than C, and this is B. B structure is missing. I hope we will be still able to, if I brick it, then so be it. Enable CS, and then we need disable CS as well, which is basically setting it back to floating mode. We can optimize it later, function first. So goal would be to get the data sent over SPI and receive it on the other side. Hey Zigzag. Receive it on the other side and set the LED. Just a basic example. Interrupted how? I mean, if you, I don't look sad, I look tired. I'm always tired recently. Don't know why. It's already like my day is quite long. Although I slept in today. Wasn't that bad. Floating, in floating, here we go. And then we don't need to set it here. It's floating anyways, so disable it. If it's push-pull, then it's acting against it. We will find out. From now on, we should see how do we test that there is something happening on the CS lines. Where is the CS line? Let me check which pin it is, so we can maybe test and see there is something happening that needs to load. Frühjahrsmüdigkeit, Ulis. Matthias, oh, wer bist du? Who is this person who calls me Matthias? CS is center pin. It's the worst to debug. Yeah. That is a supercomputer, so yeah, I can't see that. Can't test it really. Okay, let's see if I can still program my Okay, I can still program it. Woo! Hersteller. Ich bin der Hersteller. So here, this is our test device. The supercomputer has device, and this is the thing that we are building, and this is one part of it. Can resolve. That's the issue that we opened before. Delete. Yeah, no, what I'm doing right now is I'm just disabling the CS line, like letting it float. So I'm not sure how well everything will work. Now, what we need to test now is to see if we receive something on the other side. So we can, but I'm really tired right now. I'm not sure if I can go on for much longer. Okay, that is level 0. We level 1. We need level 0. That's like file new window. Let's just start. Copy what we got there before. That's CH 570. Boop. 570D. And this is level 0. Code ultra cluster finish. Here we go. Startup. Yeah, there is no source main. UART tests. UART RQ handler. Yeah, I don't need UART here. I don't need this tests. While 1. Pin debug enable sysclock PLL. I will leave that as an example how to set the pins because the syntax is slightly different. Yeah, we don't need Chinese commands. I'm not very fluent as of now. Common, I also don't need that, and I don't need other stuff. Compact high code. This means this is running. This will be copied by the initial handler, will be copied into RAM and ran from RAM. Here. Is it cool or is it cool? And what I think is we can basically compile code and just load it into this area and run it just like as we uploaded it to there. So It shouldn't be that hard, like to upload it, the code upload to and run directly from SRAM there. We provide all the functionality around the LED and so on. Okay, so let's and how did I call it? Client or SPI host? Okay, init SPI client. That's what I need here. My interface. Woof. Okay, let's include. Okay. Now, LED. I need the example that I was using before to set up the LEDs. Okay, this was my code. Cool, easy. Set LED. That's PWMX. The main clock capacitance. Okay, 18. I think it was 12. Anyways. That's easy. Look at that. That's like a few lines only of code here. It can be so easy. So it looks like a different team developed this part, or at least they didn't want to stay compatible anymore with STM. So 16-bit cycles, and that's basically it. Now we need The SPI thing. I will just do SPI here. This is SPI. Two-wire mode, no more modes. SPI buffer. Master mode. Slave mode. Okay. So it is FSPI mode. SPI normal mode. Okay, so my switch. This is now slave mode. And there's two-wire mode. That's interesting. Okay, I want slave mode receive. DMA, and then there is slave mode transmit and receive. Wow, that's cool. Receive byte. Is it so easy? This would be weird if it's so easy. Debug init. Wait, that's debug. Okay. Mode config. Pull up. In pull up. Pin 4, 5, 6, 7. SPI slave init. Six, 7, yeah. 6, 7. 4, 5, 6, 7. Okay, let's check. Let's check our design on that. No. Four, 5, 6, 7. It is what it is. But I don't think with... Okay, it's pull up. It doesn't harm. Slave init. Okay. And what now? Set LED. Okay. While 1 I need to invert LED, I think. Yeah, act out low level. That's what we want. Set LED. Stupid name. 8 and then SPI, basically V0 minus V. Okay, so we should get more or less the same thing. That's it. Okay, let me program that. Do you think we will get it? Where's the... This is the programmer. Where's the pin? I don't think we will be able to receive 30 megahertz SPI correctly. I hope so, at least. Maybe we will receive something. All right. Okay. Which one do we program first? Like this one, huh? Here. Doesn't change. It's a fixed value. Wait. Looks like full white or something. Is it changing? No. Let me change. Change everything to 0 here. So we know okay. Okay, now it's off. So it doesn't receive anything over SPI. What I can do, I can make the SPI slower and see if we hit just the limit there. So let's go to level 1 and do the SPI. Prescaler. What is it? Prescaler. Okay, let's do like really slow ones. me check if we get anything on. Yeah. Oh, this is slow. It also doesn't look like it's right. Huh? It's weird. Huh? Wondering if the pull-up is not what I want. Okay, I'll leave that one like that. I guess I might want to add some wires so I can easily program that any times. Okay, let's check level 0 again. Pull up SPI slave out, that's 6 needs to be pull up. Pull up the others as are basically floating because we have, yeah, otherwise we probably overloading the other one, not sure. Okay, don't see weirdness going on. Wait a second. Why is the LED off? This one. I think this might be boot looping. or something. Overloading and shutting down, or but it's not hot or anything. Okay, let's do not oh, I didn't initialize SPI client init LED. It's not only doing LED stuff. Oh. Something else is going on with the SPI here. Oops, I touched with the wire the wrong thing here. Okay. Need to be careful not to short anything. Okay, let's do again. Send SPI hosts. Okay, now the LED is on again. Enable CS. Which one? Let's start with one first. Let's break it down. The lower one, which one is it? The lower one that I program is 15. Damn it. Okay. No, B15C0 A0 CS0. Come on. A0. Okay, yeah, that's A0. That is pin 4. Pin 4. PC15. Oh, yeah, that one is the worst to start with. Okay. Hey Basil. C15. So basically we would need to do... Yeah, but this is like a special pin. I might need like to reconfigure it or something. Maybe I should try a different channel first. What else do we have here? The one here is A16. Yeah. A16. Pin 50. Pin 50 is A15. All right. A15. Wait a second. This is wrong. This was wrong all the way. I don't know what I changed. I basically did whatever. This was wrong. We need to do A and C, not... Oh, okay, yeah, that was an issue. So let's try again. I will run it full. Enable CS. Why does it complain about that? Zigzag, who are you? If you call me by my real name, then you need to reveal yours as well. Es geht einen Supercomputer, den ich baue. All right. Custom mini chip. No, it's not a custom mini chip. It's just an array of MCUs. Wait. It's programmed, but it still doesn't do well. Let me check if we can do... Oh no. Yeah, that's something. Need to concentrate for a moment. See what the issue is. Okay, it has no issues when I do that. Let's do until 15. What is it doing then? Still working. 16. Or let's say 29. Because I think... Oh yeah, now it stopped. 28. It's conflicting with something there. It's probably the programming pins. The 20. I think there is still an issue. Artsy, huh? Because I see only blue when I do that. We're talking about this little LED there. Still 16. Now it works. What did I do wrong here? A0. What is A0? Wake up ADC. Does it conflict with the mapping of the PWM? That would be weird. I mean, A0 was the original pin of the PWM, isn't it? See it here, I think. No, it was A2. Yeah, something's off in the code. I'm missing it. I don't see it. Okay, then let's leave it with C for now. But now it should send and receive data. So let me check with the scope. Yeah. Oh, whoa, is this slow? Okay. Here. You can see data bits. This prescaler is weird. Okay. Pips, I think I need to disassemble that, I mean the code, and see what's happening there. It's currently a little bit stubborn. I think I can make it work, but yeah. I'm tired and I'm somehow it's getting cold in here. Oh yeah. Okay, yeah, my heating turned off. I had enough for today. I'm not sure if I will stream and do an extra stream before next Wednesday. I hope you enjoyed a little bit. I mean, coding streams are boring. I hope we will receive some items of our shopping spree, and I will keep you updated on. Oh yeah, all right. Today is not the day for streaming, it seems. Yeah, the PC crashed, everything was. But we did some code, like starting with the code base for the Ultra cluster. I tried to establish SPI. Let's look at the little beauty. Not this beauty. This beauty. You migrated to Twitch, yeah. I felt a little bit lonely on with no messages anymore. Anyways, we fixed things. I found the missing clock channel that we needed for the LED. Started the code base. Yeah, whatever. And I hope I will be able to test successfully all the SPI before I send off the order for my board. And next time we will find out if my cosine with JC parts will work. Anyways, thank you everyone for joining the stream. Thank you for the generous donations for the Pink LED Fund, the Coffee Fund, the the Excavator Fund. Everything is noted. Almost. I didn't update the Excavator Fund values. But I will try to get the Colombian coffee tomorrow, okay? Because I have no coffee at home at all, so I will check out if I can get. What was the other? Not the Arabica. What was Tommy? What was the other one? I will try to get some. Anyways, Robusta, yeah. All right. Good night, everyone.